In this video, we're going to talk about end behavior, the degree and leading coefficient of a polynomial, how they relate, and how they compare between an equation and a graph. So if we are given an equation, what does our graph look like based on some of these aspects? So we've got either an even degree or an odd degree polynomial, and our leading coefficient is either going to be positive or negative. So recall that when we have a polynomial equation in general or standard form, the very first term listed has the largest exponent or largest degree, and that's going to tell us the degree of the polynomial, and the coefficient of that term, that's our leading coefficient. Those two things are going to tell us a lot about our graph. So if we have an even degree, so maybe it's x squared, x to the fourth, that is going to tell us that the end behavior points in the same direction, either up, up, we can say, or down, down. Now, if that leading coefficient is positive, it's going to be up, up. If it's negative, we think of a vertical reflection in our transformations, and so it's going to be down, down. So I always like to think of the most basic even degree polynomial, and that's a parabola, y equals x squared. If it has a positive coefficient, then it's a U shape that goes up. But if we have a negative coefficient of our x squared term, it's reflected down, and now all of a sudden my parabola opens down, and my end behavior is also down, down. For an odd degree polynomial, x to the first, x to the third, etc., then our end behavior is going to be opposite. So if our leading coefficient is positive, then it's going to be down, up. And if it's negative leading coefficient, it's going to be up, down. So I always read left to right. And again, I think of the most basic odd degree function. That's a linear function. So it's going to be down, up if it has a positive coefficient, which is like a positive slope. And if it has a negative slope, then it's going to be up, down. Now, what happens in between the ends of our graph may be different, right? X squared, it just loops up. X to the fourth, it's gonna have a couple turning points and look more like a W. Okay, so that what's inside doesn't matter. We're just looking at the ends of our graph. So let's look at a couple examples. So once we have a polynomial equation in general form, we can identify what our end behavior looks like, and that's all based on this first term here. So my leading term, 3x to the fourth, tells me that it's a fourth degree, so even degree, and it has a positive coefficient. I don't really care right now about what the number is, just if it's positive or negative. So positive leading coefficient, even degree. I think of a parabola that opens up, and that's going to have end behavior that is up, up. For this g of x function, we've got very similar, but now our leading term has a fourth degree, but negative leading coefficient. So now again, I can think of a parabola that has a negative leading coefficient. That means it's flipped down. So then this polynomial is going to have end behavior that is down, down. H of x here, I have, again, negative leading coefficient, and my largest exponent here is 5, so fifth degree or odd degree. So odd degree, I think of linear function. If it's negative, I think of a negative slope. So from left to right, that has end behavior that is up and down. And then for my j of x function, well, this one is in factored form. I need it to be in general or standard form here. So I would need to basically multiply this all out, but I'm really only looking at this first term. So I'm just going to take whatever the x term is for each factor here and multiply that out. So here I just have negative 4x to the third. Here, when I multiply x minus 1 out, I'm going to end up with x squared as my largest term, right? And remember, I'm just trying to find the largest degree. So, or I could also write this out as x minus 1 times x minus 1 and then times x plus 5. So basically, I'm taking an x times another x times another x, so x to the third. Multiply that by negative 4x to the third. So now I end up with negative 4x cubed, or sorry, not cubed, to the sixth. So negative leading coefficient, I end up with a degree of 6, so that's even. And again, that is like a parabola that is flipped down, so my end behavior is down, down. So there may be some instances where you have to multiply that out to figure out your degree.